Glaciers. These are a feature you'd expect to find in consistently cold climates such as Alaska or at the very uppermost elevations in Montana and Washington. As such, glaciers are absolutely not something you'd expect to find in Hawaii due to its consistently warm and tropical climate today, averaging 73 degrees Fahrenheit or 22.8 degrees Celsius at any point in the year. So, if that's the case, why are there glacial deposits on Mauna Kea? Look around, and these are not freak tiny and isolated deposits either. No, they extend across much of its upper edifice, encompassing an area of 27 square miles. As during the repeated glacial cycles of the Pleistocene epoch, Mauna Kea actually contained an extensive and thick glacier which averaged 100 meters or 328 feet thick. Altogether, this glacier contains 7 cubic kilometers or 1.68 cubic miles of ice. Taking an extent an estimated 20,000 years ago, I have edited this image to show what this would have looked like from Hilo, Waimea, and the summit of Mauna Loa. About that last image, no, that's not a rendering error. You don't see anything because that view from Mauna Loa's summit is completely obstructed, being buried underneath, you guessed it, another glacier. While no glacial deposits today remain on Mauna Loa, that is not because it never had any glaciers. Instead, Mauna Loa has been such a highly active volcano with hundreds, perhaps even 1,000 or more eruptions since the last glacial period ended, meaning any deposits which did exist on its edifice were buried by hundreds of feet thick of younger lava flows. But since we have nothing to work with today in regards to the likelihood that Mauna Loa for a short time once had glaciers, let's head back to Mauna Kea. After all, Mauna Kea not only still has abundant telltale glacial deposits, largely till, but it also has pretty clear-cut evidence of subglacial eruptions and even some evidence of a phenomena most commonly seen in Iceland. Specifically, a glacial outburst flood known as a Jökulhlaup. Do you see this dark gray ridge? While highly eroded, it contains pillow lavas and is thought to mark the remnant fissure of one such subglacial eruption around 70,000 years ago. Any such subglacial eruption would have melted substantial volumes of overlying glacial ice, causing large volumes of meltwater to build in volume behind terminal moraine deposits. These would build in volume until they cause an inevitable failure in a section of moraine, releasing a large torrent of water down slope at high speeds. Such repeated Jökulhlaups from subglacial eruptions ended up carving deep ravines through straw and erosion, which can be seen today at both the Pohakuloa and Waikahalulu gulches. It would have been an interesting and terrifying sight to witness this ancient spectacle, and I want to remind everyone that Mauna Kea was actually taller during each of its either 3 or 4 separate periods of glaciation. I do not simply mean from erosion due to its low eruptive rate in the times since, but rather since Mauna Kea became so tall, it pushed downwards into the mantle as the amount above and below a certain point maintains a balancing act of sorts, resulting in subsidence of 2.5 millimeters every year. That may not sound like much, but every 10,000 years after Mauna Kea reached its peak height of just under 15,000 feet elevation, it has subsided by 25 meters or 82 feet. During Mauna Kea's glaciations, advancing glaciers grounded down nearby rock, somewhat smoothing much of its summit area. The furthest any individual glacier likely reached downslope was what was at the time an elevation of 10,170 feet. However, continuous or near-continuous glacial coverage would have occurred above 10,800 feet. With that in mind, here are the extent of glacial deposits from the 3 largest periods of glaciation at Mauna Kea. Specifically, from 180,000 to 130,000 years ago, from 75,000 to 60,000 years ago, and from 40,000 to 13,000 years ago. These deposits are part of the reason why today so much of Mauna Kea's upper summit region has a distinct appearance and color, and why it is protected as part of an area called the Mauna Kea Ice Age Natural Area Reserve. I hope that you found this video interesting. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.